As I mentioned before I started recording, a lot of math boils down to what's the least I can know and still be sure. And so we don't want to have to know everything. Obviously, if you know everything, that's kind of what you did yesterday. If you know everything, you can find out if it's similar or not. And we're going to specifically talk about triangles today. So please keep that in mind, maybe highlight it or something, so that you know this doesn't work for, say, a quadrilateral. And here are the three ways that basically are enough. Angle-angle similarity, you can probably figure out what that means. You obviously don't have to write everything. Okay. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles pretty much, they have to be similar. But again, you need to know it's a triangle, and that makes sense. I mean, you see angle-angle, obviously that's what that means. That's because if you know two angles, don't you kind of already know the third? Just by logic. You know, if you know one's 50 and one's 100, you know the other one's 30, right? Because there's got to be 180 total. And so again, it's boiling down to what's the least you need to know. Again, the key here is that we're talking similarity, not congruence, because angle-angle, remember, that's not enough for congruence. Yes? Yes. And what is that symbol for similar? Who can tell me? Yes? The squiggle, sometimes it's in Spanish it's called the ñ. Yeah, I think I called it a tilde yesterday, but it's an ñ. But it is a tilde, but it's on top of the n, which calls it an ñ. Yeah, there you go. It's a tilde. I had to think through that there for a second. Sorry about that. Well, obviously, side-side-side similarity test. You should know what that is. If the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. So this goes to the question that was asked earlier. If you know the three sides and they are proportional, is that good enough? Yes, if it's a triangle. All right. Doesn't necessarily have to work for any other figure. Okay. Because of how the side-side-side works. There's no other way to draw it, basically. But if I start talking about a quadrilateral or a pentagon, there's lots of ways you can start drawing those. So yeah, angle-angle, that's good enough for similarity. Side-side-side, good enough for similarity. And side-angle-side is also apparently a good similarity test for triangles. And you probably already know what that is too. And you can obviously paraphrase this one. I wish I knew how to get rid of that. That would be great. That little arrow thing's bothering me. If the measures of two sides of a triangle are proportional to the measure of the corresponding sides in another triangle, so basically say the sides are proportional. But this is big. The included angles are congruent. So again, sides proportional in the included angle. And that's what side angle side means. You're so smart, you already know that. Then the triangles will have to be similar. These are the three that we are guaranteed. There are just the three, unfortunately. Because a lot of work has been done by other mathematicians to find out if any other ones would work for sure, and there are not. Okay. Again, definitely, I would take some time to paraphrase that one instead of writing everything. And as it says at the bottom, it is important to note that the previous similarity tests only work for triangles. Any questions on those three? No? All right, here we go. Determine whether each pair of triangles is similar. It's a pair, so that's why it's is. Okay. If similarity exists, write a mathematical sentence relating the two triangles. That sounds kind of complicated. And then give a reason for your answer. Wow, this is a pretty hard problem for this early in the morning. Well, first thing you should always check is, well, are they the same polygon? And they're both triangles, so we got a shot. And then what we're going to do is, if it's a triangle, we then know that we can try one of those three. We can try, what is it, angle, angle, side, 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 or side, angle, side. What do you think? As it sits right now, do I know? Not quite, but it doesn't take a whole lot of work to figure it out, does it? Because all I have to do is figure out either angle A or angle E, and then I've got angle, right? Because the math actually works out. That this angle up here has to be 32, right? So then do I have to go and get that one over there is 48? You can if you want, all right? But really it boils down to that, yeah, this has 32 and 90, that has 32 and 90. Well, of course, 58 has to follow then. But really all I needed to know is that the two angles are congruent. So we are good. We do know that these are similar. So there it says, if similarity exists, write a mathematical sentence. Well, what do you suppose it means by that? Well, just go ahead and say that triangle and just name it somehow. A, B, C. And what should be a good, it's kind of like the middle, the meat of the sentence here. We could say congruent, we could say greater than, we could say equal to. There's lots of things we could put there. But what are we going to put? What do we know? Similar, that's it, right? That's what we know. And similar to which triangle? I like to be very careful when I do it. You really don't have to, but I like to, and so let's do that. So A matches up with D, and what did I put next? B. So B matches up with F, and C matches up with E. And how I did that is I just matched up the angles. Don't think it's always alphabetical, all right? Now what's my reason though? Angle, angle, similarity test. So angle, angle, similarity test. Yes, I am pretty much that lazy, that I use the symbol for similar instead of writing it out. And try letter B right now on your own. Go. Again, you are to find out, are the triangles similar? If they are, make a sentence and say why. So go ahead, try that right now. All right, who would like to share their answer? Yes. Okay, we hear a yes because of side, angle, side. Would anybody else like to share their answer? Yes. Okay. A lot of reasons there. This person said no, basically because they said angle, side, angle. I don't quite see that, but I do see side, side, angle. Yeah, I think they just misspoke. That's side, side, angle, right? Is that one of them that we used? No, it's not. That's even illegal for similarity. It's illegal for congruence. It's illegal for this one too, because we only have three. We have angle, angle, side, angle, side. That angle has to be what's called included, meaning in the middle. Now, really, why is that? Why doesn't this work? Obviously, people did all this work for us to tell us why this doesn't work. Why does it not have to be similar? You try and figure it out. I think it'll mean more to you if you look at it that way. Yeah. Oh. Go ahead. Well, she brings up kind of an important point here. Do you really know which side matches up with which side? You don't, do you? Could the 12 be paired kind of, and this is a point that somebody brought up as I was walking around, could the 12 kind of be paired up with, say, this one? Yeah, if I just reflect it, right? But what if I spin it? Could the 12 also come down and be paired up with the 6? Yes, you don't know, do you? Obviously, the 4 has to match up with the 8 because it's across from 25 degrees. But the 12 could match up with the 6 or the spot, I don't know. So how can you possibly know the proportion if it could be in 2 spots? You don't. Okay, and that's the problem. And for those of you that don't see the spinning, that's kind of why I was messing around before we did this. It could match up like that, right? Where the 12 and the 6 would match up, or it could match up, and this may backfire. Sometimes it does freaky things when I do this, so if it does that, we'll just stop recording. But could match up that way. We don't know. Do you see how the 8 and the 4 are still sitting there, and the 5s is still kind of working out? But the 12, we don't know where that goes. We don't know where the 6 goes. And so that's why this is not good enough. We don't know. Okay, so don't say this one, because basically the angle is not in the right spot. The angle has to be between the sides, not just wherever it feels like. So this one is a no. Basically, you could say because side-side angle is really not one of them. Okay, and here's the last one. This is used a lot. This is how you can use triangles a lot. There's a 6-foot tall man stood, so his shadow ended at the same point as the shadow of an obelisk. That's an obelisk right there. So basically the Washington Monument is an obelisk. But this particular one apparently is not in Washington, D.C. because of the hieroglyphics on it. The man's shadow was 5.1 feet long, while the obelisk shadow was 17 feet long. We can actually find out how tall the obelisk is based on all that information. Basically because of how the man is standing there. Okay, and so some of you are saying, what does this have to do with triangles? Okay, but you can draw in basically 2 triangles. Okay, make it straight when you do it. Right? And then there's one right there, right? So in other words, we have a small triangle and we have a big one, correct? One inside the other. Well, first, are we guaranteed that these 2 triangles are similar? That's what some people just take for granted. Well, basically, this angle right down here is in both of them, right? It's right here and it's right here. The other one that you could actually take either one of them. We will assume that the monument was built properly, right? And the man is standing straight up. But really, we don't need that one because the sunlight's going to come down through there at the same angle, correct? At the same time of day. And so we could say that that's congruent to that. So there's your angle. These 2 triangles have to be similar. Are they going to be congruent? Of course not. The man's not the same size as the obelisk. Right? But now what we can do is start putting in information. First, I will put it in this picture over here on the right, and then I will put it in the 2 separate triangles. So the man is 6 feet tall. So basically from here to there is 6 feet, correct? So where should I put that in which triangle, though? The smaller one or the bigger one? Smaller one, and on which one? Yeah, it's on the right part. I was going to say hypotenuse, but we can. So 6 feet goes right there. All right. We know where are we at here. The man's shadow is 5.1. So that's basically from here to here. That's a shadow, right? 5.1 feet, I hope. Yep. Okay. And so that goes down here. The obelisk shadow was 17 feet long. So basically from here all the way over to there, 17 feet. Good thing these are all feet, so we don't have to convert. But we could convert because we are doing proportions. That's an easy way to convert measurements. So how tall is the obelisk? So in other words, we want to know that, correct? And what do we put normally when there's something we don't know? Yeah, some kind of variable. And we will choose x. And so these are similar, and so what we can do, seeing we know they're similar, is we know the sides better be proportional. And so we can go ahead and set up a proportion. The nice thing is there's 2 ways you can set up this proportion and get the right answer. That's the really nice thing about triangles. Here's what a lot of people like to do. Go with the one you know, 5.1 over 17 equals. So how would we write the other ratio? Yes? I've been told 6 over x. So 5.1 over that, 6 over x. Is that correct? That'll work. So go ahead and solve it right now. All right, would anybody like to share their answer? Yes? 20? That's it? 20 feet? That's all the taller that thing is?
Yeah.
Apparently. Now, raise your hand if you set up a different proportion than that. Would you like to share your proportion? This person over here in a red shirt.
The green beans.
Yes.
6 over 5.1. X.
Is it okay to set it up that way? With triangles, it is. Because as long as you follow the pattern, it doesn't matter. So 6 over 5.1. X over 17. It's the same pattern. So you're fine. And you notice you end up multiplying the same numbers anyways. So it doesn't matter. So it is 20 feet. Any questions?